Hello, fifth graders. We're going to be talking about our lesson today with prisms. We're going to be looking at them, going over things with them, and kind of analyzing what do they have with them. Your book on page 581 shows a bunch of prisms there. We're going to look at a few of them here, though. So we have a rectangular prism. Prisms are based on the face that the faces that it has. So this one here, here's a rectangle. That's one of the faces of it, and so this is based on the rectangle there. Let me get my pen up and running here. Okay, so let's take a look at these. See if we can identify some of the prisms and why they're called what they are. You had a lesson already in these geometric shapes. But here's a rectangular prism. See that rectangle right here. Okay, that is the shape that it's based on. When we look at the amount of vertices, remember vertices are points. If I look at the vertices, here's one, here's two, there's three, there's 4, 5, 6, 7, 8. So we have 8 vertices on a rectangular prism. Now edges are different. Edges are those places where the faces meet up. Okay, so, oops, hold on, didn't want to do that. I'll take that back down. Okay. Just get rid of that and go to the page before. Okay. So going back to here. Let's change our pen color here. And we'll take a look at the faces. All right, so the faces we have are where the two things meet up. So this, oh, it didn't change the color. Where the edges, so that's an edge, one edge, two edges, three edges, four edges, 5 edges, 6 edges, 7 edges, 8 edges, 9 edges, 10 edges, 11 edges, 12 edges. So the amount of edges we have on this is 12. Okay, we have parallel rectangular faces. There's the rectangular face in the front and the rectangular face in the back, and they will never meet up with each other because they're on two separate tracks, as I would call them, right? Same with here, top and bottom, not going to meet up because it's a rectangular item. So they have different parallel areas to them. When we look at the next one, this is what we call a pentagonal prism. Tongue-tied today. Pentagonal prism. And this is based on a pentagon. And hopefully you'll be able to see this pentagon here. We've got the line here, the line here, the line here, here, and here. And that makes up our pentagon. So it's called a pentagonal prism. And if we look at the back face over here, it matches this. It's another pentagon. They're parallel faces. And there you have another pentagon. So that pentagon and that pentagon match up with each other. And when we look at the vertices on here, how many vertices do we have? Well, let's take a look at the vertices now. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Do we get them all? Let's see. Nope, we missed a few, right? What did I miss? 1, 2, 3. Oh no, we got them all. Okay. So vertices wise, on this one, we have 10. I see a pattern here. A pentagon has how many sides to it? It has 5 sides. A rectangle has 4 sides. 4 times something equals 8. 5 times something equals 10. We're going to see if that's a pattern that holds true or not. And we're also going to look at our edges here. So our edges for our pentagonal prism, when we look at the edges, we're going to see how many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. No, 15. Sorry, 15. We're going to mark them because this is where it gets difficult sometimes to follow. So here's an edge. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 edges. 15 edges. 4 and 12. 5 and 15. I see a pattern there. We're going to take a look and see if that pattern is the same on the next page. So first of all, we have, like I said, 8 and 12, 10 and 15. In this polygon, again, you have, or this prism, you have parallel lines and parallel faces. Some are not parallel though, because if we look at these two faces here, if I put these together, they're going to cross each other. They're going to meet up, right? And these ones will meet up. But the front pentagon and the back pentagon will not meet up. They're parallel to each other. All right, a right triangular prism. So for a right triangular prism, that means that right here and right here, we've got that little 90-degree angle. So if we look at these, I have, let's see how many vertices we have. Well, a triangle has how many sides? 3. Let's see if our test holds true. 1, 2, 3, 4, 5, 6. We have 6 vertices, and a triangle has 3 sides. So the faces, or I mean the edges that we have, let's see if that works. 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 edges. It holds true, doesn't it? So when we look for vertices, we take the face number, which is 3. The triangle has 3. The number of lines for the face, and times that by 2, and that's going to give me 6. This one, for edges, we take the number in a flat figure of the triangle and multiply that by 3, and we get 9. These prisms have a pattern. Same thing with our equilateral right triangle, or equilateral triangular prism. With the right triangle, though, this has a perpendicular faces right here. Okay? They have perpendicular faces. And what that means is that I have a face here, the one on the bottom, and I have a face along the side that will cross each other with a right angle. And because it'll cross each other with a right angle, it's considered a perpendicular face. So if I were to give these numbers, or letters, if this is A, B, C, D, E, F, I would say that face AEDC is perpendicular to face ACB, or ABC. Okay, because this back wall is perpendicular to the floor. And that means that it has perpendicular faces. So perpendicular faces, it would be ACDE is perpendicular to, oh no, that's pi. Didn't mean to do a pi sign. All right, I'll just write it out. Perpendicular to ABC. It's perpendicular to ABC. Okay? And an equilateral triangle, it does not have perpendicular faces, because if I were to take this one and that one, they're going to meet together. And they don't have that 90-degree angle. They have that little angle, an acute angle. All three of these have acute angles. And they don't have that 90-degree angle. In order to have a perpendicular face, you have to have a 90-degree angle. And these do not. Okay? So that makes it a perpendicular face. Our next ones, we're going to look at our trapezoidal prism and an octagonal prism. On a trapezoidal prism, we look at how many vertices we have. And a trapezoid has four sides, so it should be that it ends up being 8. Let's see if we're right. 1, 2, 3, 4, 5, 6, 7, 8. It has 8 vertices. And how many edges do you think it has then? We said the face corners times 3. So we have 4 then times 3, which gives us 12. Let's see if we have 12 edges. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yep, we have 12 edges. Octagonal prism, we have how many sides in an octagon? 8. So my vertices, I multiply that by 2 times 2, so I have 16. My edges, I multiply that 8 by 3, and I get 24. So I should have 24 edges. 8 here, 8 there, that's 16, and then the 8 that connect the two of them together, which makes it 24 edges. Now, as far as any parallelisms, you have in an octagonal prism, you're going to have these rectangular faces, and those are all congruent rectangular faces. They will not run into, some of them will not run into each other, like the top and the bottom, the one side and the other side. But because it has that even number too, that makes it easier for us to figure out how many congruent faces it has. You can kind of see the rectangle here. I wish we were in person because it would be easier to show you with these actual figures. All right, a trapezoidal prism, very much like the rectangular prism, except these lines will intersect each other. Whereas with the rectangular, we have that right angle, and those will not intersect each other if it's straight up and down. And so there's just a little bit of difference with those types of things. All right, there's not a lot to go over. When you look at 581, it'll explain a little bit more about the congruent rectangular faces. And then on page 582, there's more about the that perpendicular rectangular face that I was talking about earlier. All right. One thing I want to go over with you before we move out of our lesson completely is how do we change those improper fractions into mixed numbers, because that can be a little confusing at times. So remember that when we have a fraction, if I have like, let's say 18 over 3, this is just another way to write a division problem. So this means that I take 18, the top number always goes inside the box, the bottom number's outside, right? Denominator out here, numerator inside. 18 divided by 3 is 6, so 18 thirds would equal 6. All right, so 10 thirds equals something. So the 10 goes on the inside, the 3 goes on the outside. How many 3's can we get out of 10? 3. 3 times 3 is 9. Subtract. We have 1 left over, so 1 becomes our numerator, and our denominator is the guy outside the door, so we have 3 and 1/3. Okay? That's how you come up with this changing improper fractions into mixed numbers. You can do that division problem. Or you can say to yourself, okay, I have 3, 6, 9. That's as far as I can go before I'm going to fall, before I'll be too many. So that's 3. And then if I subtract that 9 from there, I have 1 left over, and that third. Okay, so it's going to be the same answer, but that's just 2 different methods of finding that mixed number that you want to find. All right, hopefully it was okay with the whole prisms and things, the vertices and that are in your book, and the same with the edges, they're in your book. So take care. You have a worksheet for today. Hope it all goes well, and I will see you after the weekend. Have a great weekend, and we will talk to you on Monday.